Good morning, students. Here we are with the next topic of the chapter acids, bases, and salts. So, today we are going to study that in last experiments, activities, and topics, we read that any metal, whether you take sodium or zinc, you take any acid, HCl, H2SO4, and any other acid. But general property says that when a metal reacts with an acid, it will always form salt. Now, salt will depend upon which metal you have used and which acid you have used. But one thing common is liberation of hydrogen gas. Similarly, you said any acid and any metal carbonate. So, we have taken two examples of acids, two examples of metal carbonates. The thing which differs is type of salt formed. In one case you are having NaCl, in another you are having zinc sulfate. But the common is liberation of water and liberation of a gas CO2. So, any acid reacts with any metal carbonate, the common product formed is salt, water and carbon dioxide. Then we said any acid reacting with metal oxide will give you salt and water. Any base with non-metallic oxide will give you salt and water. That means these two are undergoing neutralization reaction. Further we said any acid, any base will give you salt and water. So, when you keep on saying any acid, that means but still having some common products, which shows there has to be something common in all acids. Similarly, you talked about properties of bases. Bases also show some general common properties. You don't have to say that this is the property of NaOH. When you talk about neutralization, if NaOH performs neutralization with acid, calcium hydroxide, which is a weak base, also performs neutralization reaction. So, there has to be something common between all acids and bases. And that, how do we find out that common thing? For that, they have taken up an activity 2.8. So, what do they say? That if you take an electrolytic cell in which you take two electrodes, attach it with a bulb, these two rods are called electrodes and the liquid taken in the electrolytic cell is called electrolyte. So, that electrolyte, if you take it as HCl solution or NaOH solution or NaCl solution, any of these solutions, and switch on the circuit, you will find that the bulb starts glowing. When you say bulb is glowing, that means electricity is passing through this solution. Passing of or flow of electricity can only be due to movement of ions. From where do we get this ions? We have got electrolyte, and that electrolyte is in the form of solution, and that solution is in water. We call it aqueous solution. So, when aqueous solution is taken in this electrolytic cell, the substance which you have taken, HCl or NaOH or NaCl, it breaks down to give ions. So, glowing of bulb shows that there is a flow of ion. And from where do we get the ions? We get it from the substance which you have taken in the solution. Instead of this, if you take glucose solution or maybe ethanol as an electrolyte, you will see that this bulb will not glow, which means that these substances are not furnishing any ion in solution. So, no ions, no flow of electricity, no glowing of the bulb. That means acids and bases, on dissolving in water, they furnish ions. So this is what we have seen, that if bulb glows, that shows that there is a flow of electricity. That means there is a movement of ions, and this shows that these substances HCl, NaOH or salt, when it is dissolved in water, they generate ions. Now instead of this, if you take ethanol or glucose, the bulb does not glow. That means no ions has been generated when these are dissolved in water. They have given you another activity, and that is, if you take a test tube, take NaCl and add dilute sulfuric acid to it. So try to write down the equation, NaCl plus H2SO4. So it will give you Na2SO4 and HCl. So you will write down this equation, NaCl, H2SO4 gives you Na2SO4 and HCl. This HCl is in the form of gas. So when you put them in the test tube, the gas evolves. This gas is HCl. So when you think of HCl, I know you must be thinking a bottle having that solution of acid, which is HCl. But actually HCl is a gas. What you see in the lab is HCl dissolved in water. So you treat it as an acid. If you let this HCl gas hit a blue litmus paper, and remember that blue litmus paper is dry, there is no moisture over it. So this blue litmus paper will show no change in color. So had this HCl gas been acidic, it would have turned blue litmus red. Now you take this litmus and make it wet. So now there is a moisture or water on this litmus paper. Now when this HCl comes in contact with wet litmus paper, you will see that litmus turns red. That means HCl does not show acidic property in the absence of moisture. This shows that water is a necessary requirement for the liberation of ions, and only ions are responsible for showing the acidic or basic nature of a substance. So dry HCl is not acid. It is the aqueous solution of HCl which is acid. So when you are writing these two activities, remember that your activity should have an aim, procedure, simple 2 lines, that this is how the system has been set. And what do you observe? Make a diagram, write the related equation, and then show the inference. That means it says that only in the aqueous solution the ions are generated, and those ions are responsible for making this wet litmus red. That means only aqueous solution shows the acidic property and not dry HCl gas. This is a very important question which is asked in your exams. So it can be in the form of activity, or it can be simply in the form of questions like, you can write down this question. What happens when dry blue litmus is exposed to dry HCl gas, and why? Okay, so you can write down this answer as an inference of activity 2.9. So we have acids. Now acids are of 2 types. You have earlier read about strong acid, weak acid, but same acid can be in the form of dilute or concentrated. So if you say an acid HCl, then it is dilute HCl and concentrated HCl. Now in general, whether it is dilute or concentrated, what is common What is common is that what happens when you take HCl? You expect HCl to have H plus and Cl minus ion, but this will not happen until you put it in water. So when HCl is put in water, it breaks up to give H plus and Cl minus ions. This is called hydrogen ion. But hydrogen ion cannot exist on its own. This H plus combines with H2O to give H3O plus. This is called hydronium ion and Cl minus. Let us try it for H2SO4. H2SO4 has a tendency to give H plus and SO4 2 minus ions in the presence of water. So when H plus is generated, this H plus combines with H2O to form H3O plus and SO4 2 minus. So what we can say, that an acid is the substance that furnishes H plus ions in the presence of water, which in turn gives you H3O plus. So what you get in the solution is not H plus. What you get in the solution is H3O plus. This is called hydronium ion. So by these two examples, you could see that something which is common in both the acids is hydronium ion. The Cl minus, SO4 2 minus, they are different because of the difference in the two acids. Common thing is furnishing H3O plus in water. Similarly, when you take a base and add it in water, the ions get separated and you get Na plus and OH minus. You can see that I have written aqueous in the bracket. This shows that this OH minus is no more attached to Na plus. Na plus and OH minus has been separated and they have gone in the intermolecular spaces of water. So we write it as Na plus aqueous and OH minus aqueous. Now you take any of the bases, only positive ions are different, but all of them are furnishing OH minus ions. No matter which base you have taken. Yes, number of OH minus ions may vary depending upon the formula of the base, but OH minus is common in all the bases. So what we have seen, that all the acids furnish H3O plus in aqueous solution or H plus in aqueous solution, whereas all bases furnish OH minus in aqueous solution. And now this can explain very easily what happens during neutralization. You take up any acid will give you H plus and any base will give you OH minus. So this H plus and OH minus is common in all the acids and bases. So you take up any acid H plus, HX, any base BOH. Requirement is of H plus and OH minus to call this one as acid and this one as base. So HX will give you H plus and X minus. BOH will give you B plus and OH minus. This positive will now combine with this negative and you get this salt. That is why the salts are different in all neutralization reaction depending which base you have taken and which acid you have taken. But H plus and OH minus, they are common in all acids and bases, which will always give you H plus and OH minus will give you H2O. So H2O is common in all acid base reaction, whereas salts may vary depending upon the type of acid you have used. So you can also explain what happens when you say any acid reacts with metal carbonate. So any acid will give you H plus, X minus, carbonate will give you M plus, CO3 2 minus. This M will combine with X and you get the salt. This CO3 will give you carbon dioxide. One oxygen is left here which will combine with this hydrogen to form H2O. So any acid combines with any metal carbonate will have only this product as different, but these two are common. You can apply the same thing with any metal reacting with any acid. So acid will give you H plus X minus. Metal will give you M plus. This M plus will combine with X minus to form salt, and this H plus is liberated as hydrogen gas. So you say metal reacts with acid to liberate hydrogen gas as common. Metal acid reacts with metal carbonate to liberate carbon dioxide as common. Acid reacts with base to form salt and water as common. So this thing can be explained only when you understand that all acids have one thing in common, that is H3O plus, and all bases have one thing in common, and that is OH minus. So that is how we say that any acid reacts with any base to form a particular compound. Now acids are of two types, dilute or concentrated. So when I say HCl, HCl will give you H plus no matter what amount of HCl is present in that water. But if number of H plus ions per unit volume is less, we call it dilute HCl. If number of H plus ions per unit volume is more, we call it concentrated. Now when I say if I don't use this word, because you might make mistake while writing the definition of dilute concentrated, if you don't write per unit volume and you said less number of H plus, more number of H plus, that doesn't make any sense. I'll give you an example. You take 1 spoon of sugar and add it in half cup of water. That is one case. Take 1 spoon of sugar and add it in 1 glass of water. The only thing you have changed is volume of your solution. So first case is same amount of sugar in less volume, and another case same amount of sugar in more volume. So which one will be diluted? Where volume is more. Now take up another example. 1 spoon of sugar in 1 glass of water and 2 spoons in a jug of water. According to you, you have increased the amount of sugar, but at the same time you have increased the volume more than amount of sugar you have increased. So 1 spoon in 1 glass and 2 spoons in 1 jug. Which one will be more sweeter? 1 spoon in 1 glass. So remember, more number of H plus doesn't have any significance unless and until you specify the volume. So when you say per unit volume, that means you are restricting the volume and then deciding which one is having less number or more number. So dilute has lesser number of H plus per unit volume, concentrated has more number of H plus per unit volume. So if you have got concentrated solution, how do you dilute it? Simple, you add water to it. So similarly, if you want to dilute concentrated acid, you will say we'll add, don't use the word add, you say we'll mix required amount of water. Now mixing can be in 2 ways. Either you add acid to water or you add water to acid. It might not seem much different, but it is, because mixing of acid and water, no matter whether you put water to acid or acid to water, in both the cases mixing is always exothermic. What is exothermic? Where large amount of heat is liberated, and this mixing is pretty highly exothermic. So now if you add water to acid, you are adding water to acid, so this heat liberated will make acid splash. When you heat something, and if that thing cannot contain that heat, it splashes. So acid will splash out. So that might cause accident, or that accident means it might cause injuries to the person handling it, or it might break the glass container in which you are performing this mixing. So if you add water to acid, it might cause accident. But when you add acid to water, remember this process is also exothermic. Don't write that this process is not exothermic. This is also exothermic. But the only thing is that the heat which is liberated will be absorbed by the water, because when you are adding acid to water, water is in large amount. Now the amount of heat liberated will be absorbed by water, because water has a very high value of latent heat. You remember latent heat you studied in 9th class? It is tendency of a substance to absorb that much heat without getting evaporated or without getting boiled, right? Without changing the temperature. So as this amount of heat will be taken up, will be absorbed by water, as a result splashing will not take place. So if you want to avoid the accident, then acid should be added to water and not water to acid. So let us understand actually that what happens during dilution. Dilution is when number of H plus per unit volume has to be decreased. So suppose you have taken 1 ml of any acid. This is a very vague number. Obviously 1 ml has much more number of ions, but I have simply written it as any number. So if you say 1 ml of acid has 1000 H plus ions, right? So concentration will be these 1000 numbers upon volume of solution, that means 1 ml. So 1000 H plus upon 1 ml. Now you add say 10 ml of water to it. So number of ions will be same, 1000, but volume will become 1 ml plus 10 ml. That means volume will be 11 ml. So number of ions upon volume, if you are increasing only denominator, obviously the concentration will decrease. This is the mathematical explanation of dilution of acids. So I hope that the topic is clear. It is new, so better listen to the videos number of times before making notes. Don't simply copy it or write it from your book. It's very important to understand the concept, and then you should have some problems which can be discussed in your problem classes or Zoom classes. Thank you.